There are more reverse engineering terms. So business process reengineering. For example, if you have a very strict redesign process, then we need to understand and even deploy our system so that we can reduce our cost, improve the quality service, even the speed. So since technology is improving, so we sometimes need to optimize the organizational process and structure. So some system we might have for say flat hierarchy, or that system could be used in a other way where is a maybe aggregative hierarchy, tree-like structure. So we need to re-optimize for that specific organizational process. So it's also important task to make some re-engineering thing. The reverse engineering specification, we need to extract actually the system specification, what is doing in our current application domain. And we need to use the abstracted module from the source code or design description so that we can use that knowledge when we make it re-engineering. So now, though I have given some ideas about the reverse engineering, still can. So software re-engineering is reorganizing or modifying existing software to make them more maintainable. So if we have some existing software, so we want to use for our efficiency, for our benefit, then we can optimize it or we can restructure it. So for this thing, we definitely use the software re-engineering concept. Restructuring or rewriting part of all a legacy system without changing its functionality. We know that what is a legacy system? Legacy system is one old system. We are still using that old system, though some new technology is still available. So this is we call the legacy system. So for restructuring, or we can rewrite a part or total part of the project so that we can just transform our legacy system to a new system, and we want the same output, the same input or other behaviors. The re-engineering is applicable where some or but not all subsystem of a larger system require frequent maintenance. So sometimes we need some module, and those module they fail frequently, and they have many error messages, and that's why we need to invest a lot of time. Sometimes our customer may turn back. So those systems are very expensive in terms of maintaining those, even they have the high technical debt. So in those systems, we can actually make software re-engineering. Re-engineering involves adding effort to make them easier to maintain, and the system may be restructured and redocumented. So for re-engineering, we put a lot of effort so that our maintenance become easier further. When to re-engineer? When system changes are mostly confined to part of the system, then the re-engineering that part. Confined in terms of is a very specific and it's visible that that part is actually performing poor and it's a very much cumbersome and making trouble. So definitely we need to re-engineer that part. Sometimes we actually we have our hardware or software become obsolete. Some hardware and when it becomes actually up to date, we have different interfacing with the software. So it becomes obsolete. So in those cases, if we still use the legacy system, we need the virtualization thing. So when you use virtualization, it's actually resourceful and it is expensive. So it's better to actually re-engineering that part, whether it is software or hardware. And if we are sure that we have available tools for re-engineer, so that then why not re-engineer it? So re-engineering had some advantages. One is it will actually, when we have a lot of fail in a specific module or in a subsystem, we will have higher risk of losing our revenue, losing our customers. So if we can re-engineer it, then we can reduce some risk. Even we can reduce our cost because we know that that specific subsystem that needs the re-engineering, it has a lot of cost in terms of time, money, even reputations. So this is one approach. Here you can easily see that for the difference between the forward engineering and re-engineering. So in the re-engineering, we can see that we have some existing software. From that existing software, we need to make some reverse engineering thing, that is understanding and transformation. So after understanding and transforming, then we can just implement that desired subsystem or part that will change restructure. It's actually represent the lower data flow diagram. So here is a very brief schematic diagram of re-engineering process. So in the re-engineering process, we have definitely idea about our existing software that we are going to re-engineer. So we may need to translate our source code. If it is a legacy system, we may need to change it from say Fortran or COBOL to Python or Java. We need some source code translation. Then we need to understand the course well. That's why we need reverse engineering. And we also need that if we have any architectural issues or design issues or engineering constraint, then we can improve, because previously many systems were developed in the monolithic way, but now we just segment different components, independent parts, so we can improve our structure. So in the above part, that part, after reverse engineering, we make some documentation about our program understanding. And the lower part, you see that if we have monolithic or very much integrated, then we can to distribute different module based on the roles. Then we can make the modular program. So from that modular program, and we have our original data. From that, we can use our data engineering concept. From that, our final re-engineered subsystem or the module. So this is a very brief and easily understood from the diagram. So re-engineering has some cost factor. If our quality of the source code is not up to the mark, so we must need to actually have some expense for engineering. Even our automated tool is not that much available, we'll have to bear the expense for re-engineering. Even we need to convert data, for example, if we have, say, flat files, for example, we have data in the notepads or in the maybe in a flat file. If you need to convert it in any relational database management system, so it will give some, actually, for the sake of cost, we need to convert it. Even some legacy system, the old system has very low amount of expert, because when one new technology comes, people tend to give effort learning those platform, and there are many obsolete platform, so people lose their interest to learning those. Even we lose many expert, so it's very expensive when we want to transfer from one legacy system to one new system, because it's very expensive, or their salary is very high when you want the expert staff to understand any old platform. So re-engineering approach we can give how actually the cost increases. If we use automated tools, and then it's easy to re-engineering. But we know that we have many requirements or many ideas or many contexts that cannot be completely automated. So in those cases, we need some manual changes, manual restructuring. So in those cases, actually, the cost of re-engineering likely increases. So reversing here, we can actually make some relation with the reverse engineering and re-engineering. Reverse engineering often precedes re-engineering. Yes, but it's sometimes worthwhile in its own right. So for re-engineering, we definitely have, we must need to understand the platform first. So the design and specification of system may be reverse engineered, so that can be an input to the requirement of the specification. And that the design and specification may be reverse engineered to support the program maintenance. So reverse engineering is our primary task, to understand the input, the output, the functions, to understand actually to extract our requirements, maybe functional or non-functional requirements. For program structure improvement, maintenance tends to corrupt, yes, when we have a system. Over the time, we can corrupt the structure of a program, because in a project, many people come and they make some change, fix bugs, without any good documentations. So actually, maintenance actually corrupt the system. So re-engineering, actually, we can improve the program structure. The program may be automatically restructured to remove unconditional branches. Yes. And conditions may be simplified to make them more readable. We'll see some example. For example, here you can see one logic that is called spaghetti logic. So in spaghetti logic, actually, if it is a very unstructured program, you can see that there are lots of go-to keywords. So go-to keyword is it was used previously when our conditional operators, loops were not available. That time actually go-to keyword appeared, but still many programmers may have using this go-to keyword. So if you see the structure, it's a very unstructured, there are very random go-to. So how can we improve? So here you can see that somehow we can improve that structure by using some conditional operators, by using some loops. There are some in loops. So in the re-engineering, when we restructure, we can change this actually in the business, in the control logic, business logic. Even you can say that it's a complex condition. Say here you can see that if not, and this is a very complex condition. So when you restructure, it can be very easily we can demonstrate or present, so that it is easily maintainable afterwards by the personnel who will responsible for the projects. Automatic program restructuring, actually first we need to consider the program that we are considering, restructuring. Then we can use some analyzer, code analyzer. There are many code analyzer, debugger or graph builder. It will analyze from the source code. Then we can make some representation of different, say, class file or different actors of the program. From that graph representation, we can easily generate the program, and then we can find the restructured program. But restructuring program has some common problems. For example, due to maintenance work, in course of time, we actually lost the comments. So after restructuring, so for example, I have shown the spaghetti code, and afterward we can find some simplified code. So after restructuring, our many comments will be irrelevant for that purpose. So restructuring is a problem. So what we need to do after restructuring, you need to make some documentation also. And for restructuring, we need a lot of time, because we know that our input and output are actually remains the same. But still, for the sake of re-engineering or restructuring, we need to give a lot of computational resources. Restructuring does not help with poor modularization. Yes, if our program is actually monolithic, means all the components are very much mixed with each other, that restructuring will not much help, because we may put effort in a subsystem, but that subsystem might be dependent with other system where we are not restructuring. So it's a problem, because our restructuring subsystem is one place, and it was a monolithic, so it will not put a lot of effort, a lot of efficiency. And the understanding of the data-driven programs may not be improved by restructuring if our main responsibility or functionality are related to data, then restructuring may not give a lot of leverage. So as before, so we have different abstract or modules. For restructuring, we need to restructure on the data level, we need to hardware level, we need a functional level, functional, non-functional level, even we need to process support modules. Now recovering data abstraction, actually data abstraction is completely connected with our database course or our database management system. Still, we can explain a little. Many legacy systems use shared table and global data. So previously we have the prior programming languages, they used to consider on global variables. But later, when we are very much concerned about the data, we have different systems like say encapsulations, maybe abstractions, interfacing, maybe polymorphism, and many other things. So when we have the global tables, even if we use the shared data in our memory, so in those places, it's very difficult to identify the abstraction. So it's a and data abstraction still we need common data areas, some memory, virtual memory or memory. We need to understand the data abstraction clearly because it's a very complex phenomena. If you read the operating systems, we use actually say secondary memory, even primary memory, even cache memory. So how these variables are used, so they are using in a common data areas. Even they provide functions to access and update each of the field and the data abstraction. So it's also important task in the for restructuring to recover the data abstraction. So in data engineering involves analyzing and reorganizing the data structure. Maybe the part of the process for migrating one file-based or simple file-based system to database management system. But our objective is to create a managed data environment. So these are a very common keyword for data engineering. If we have redundant files or variables, we need to clean it up. If we need to, if we have some data constraint in the legacy system, but in our new system, we do not have any data constraint. What we can do, we can extend some field of the for database schema. So we can use data extension. If we need, we also need to use data migration. So these are actually different approaches of restructuring for the sake of reengineering. So data conversion may be involved from changing one platform to another platform. Even data value conversion is very expensive. Sometimes we use hard-coded values. Hard-coded values are those values when in the source code, sometimes we fix some codes, but when we update our legacy system, we might not be interested to use the hard-code values. So we need to convert those systems. So this is the data reengineering process. we need to analyze the data. We we have two types of modules. One is that is called the summary table that we want to change. So we have two modules, that is our summary table, and we have the program that we are going to re-engineer. So in between, we have a lot of shared table, shared data, or literals, different business logics. So from that, we can convert our data. And for data, converting our data, we need to analyze the data. And finally, we got the re-engineered data. So this is data engineering process. So all those cases, if you consider, we are actually analyzing our program or structure. So that's why we must need the reverse engineering thing. Then we are targeting our main module that we are going to re-engineer. So it could be program re-engineering, or it could be data re-engineering. So that's all today.